Hi pumpkins! I hope you had a great spring break. We are now going to learn about area between two curves. This is going to be fun. Okay, so let's go ahead and start off with an example. So we have y equals x squared and y equals 2x minus x squared. So first off, what we want to do is start off by graphing each equation. Okay, so hopefully you remember x squared is a parabola. Please make sure you draw your graphs big and label. So we got y equals x squared. Now we need to graph 2x minus x squared. Now I know it's an upside down parabola because x squared is negative. But I need to know which side does it go. Does it go this side? Does it go this side? Is it over here? So the way we're going to do this, and let's just write to help graph. So what you're going to do is take 2x minus x squared, set it equal to 0. And what we're going to do is find out where this graph's x-intercepts are. So what I'm going to do is factor out an x. So that leaves me with 2 minus x equals 0. So I get one intercept at 0 and another one at 2. Okay, now what does this tell me? Again, I'm just going to kind of put this off to the side because all this is going to do is help me graph. So I know 0 is going to be here and I know 2 is somewhere out here. Again, upside down parabola. So we got here, and here's my 2. Okay. Now, let's do this. We're going to take and find this piece. That's the area under the curve we're going to look for. Let me get my lines back. Okay. Now, next thing I need to do is come up where the area is bounded. Okay. So to find the bounds, what we're going to do is set the two equations equal to each other and solve. And this will tell us where they intersect each other. Okay, push this down a little bit. So what I'm going to do is subtract x squared from each other. Get everyone to one side. So I get 0 equals 2x minus 2x squared. Now I can factor out a 2x. And that leaves me with 1 minus x. So I have an x-intercept at 0 and at 1. So here's 1 at 0, and here's 1 at 1. Not bad. Please realize at this point we still have not done really any calculus, but we're getting ready to. Yay! I know you're excited. To find the area between two curves, we're going to follow one simple rule. We're going to take the two bounds, and it's going to be the top function minus the bottom function. Okay? And this is the whole point of the graph. So here we go. Let's have fun. Remember, over here are our bounds. Okay? So my lower bound is 0, and my upper bound is 1. Now we need to realize which function is the top. So to go back to your graph, and what you want to draw a line straight down the middle where you shade it. Here's my top, here's the bottom. Okay, now what you want to be careful of when I ask you what the top function is, I'm talking about this line that does not go to x squared. Ooh, and I did not label. This is the importance of labeling. So here's my top function. If I follow it down, notice it's 2x minus x squared. So 2x minus x, ooh, got email, minus the bottom. And my bottom function, if I scoot it up a little bit more, my bottom function is x squared. So minus x squared. Now, here's one of two steps for calculus. Now, before we even do anything, my suggestion is let's clean this up. let's see if I can extend. There we go. Notice if I do this and this, I have two like terms. And what I'm going to do, and I highly recommend you do it, let's collect like terms. So this becomes 2x minus 2x squared dx. Okay, now here comes the last step in calculus. We integrate. If you forgot how to integrate, remember we're going to add 1 to the exponent, so 1 plus 1 is 2, and then multiply by the reciprocal. Okay, let's do it again. Add 1 to 2, and we get 3, and multiply by the reciprocal. And we're going to evaluate this from 0 to 1. That is our last calculus step. Again, let's make life a little bit easier. I'm going to clean all of this up. So this term just cleans up to x squared. This term cleans up to 2/3 x cubed from 0 to 1. Now it's the top minus the bottom. So plug 1 in. So 1 squared minus 2/3 times 1 cubed minus, and if I plug 0 into both of these, we get a big old fat 0. Okay, so 1 squared is 1, and all this goes to 2/3. In order for me to add, I must have a common denominator. And my final answer is 1/3. Okay, here's a little side note. Your answer should always be positive. Okay. If you get a negative answer, more than likely you got your top and bottom equation mixed up. Okay? And so I hope that helps. That is when we have y equal equations. Going all the way back up. So when I have y equals, it is top minus bottom. Whoops. Okay, so let's do another type of example. Okay. Let's try x equals y plus 1 and x equals 1/2 y squared minus 3. Okay, now y squared is a parabola that goes on its side. That minus 3 means we're going to drop this little guy back 3. Go like that. Go like that. And this is going to be x equals 1/2 y squared minus 3. If you're having trouble graphing something linear, you can, for the moment, rewrite it as x minus 1 equals 5. Go down 1, and then it's a positive slope. And this would be x equals y plus 1. Just like before, I do need to figure out what those 2 points are. And let's go ahead and do this. This right here is the area we're trying to find. Now, I know you're probably jealous of my coloring abilities, but it's something I had to learn to do a long time ago. Yes, it's a skill. So now let's go ahead and find our bounds. So we're going to set both equations equal to each other. Okay, and then solve. So what I'm going to do is subtract y and 1 over. Okay, so 0 equals 1/2 y squared minus y minus 4. I'm going to get rid of the x squared. So what I'm going to do is multiply everything by 2. So I get 0 equals y squared minus 2y minus 8. So now I got to factor. So what times what gives me 8? When I subtract, I get -2. Oh my gosh, that is so correct. -4 and +2. I'm so proud of my little pumpkins. And so I get values at 4 and at -2. Okay, so let's put this up here on our graph. So this will be 4, not 4. Silly goose people. Okay, let's try this again. So this is -2, and this is 4. Now, if I do top minus bottom, notice I always get the same graph. So what I want to do, let's change color. We're going to have to change this because I want to always guarantee I get both equations because these are, oh, where's my thingy? X equals, my equation for area is going to be A, B, right, minus left, okay, dy. This is for only when I have x equal equations. So let's go find our area. Let's see if we can do it here. Nope, let's see. Let's back this little guy up. Okay. So here we go. We're going to integrate from -2 to 4. My right equation is right here, which is the line, which is y plus 1 minus the left equation, which is that parabola, is 1/2 y squared minus 3 dy. Now, the hardest part here is going to be the algebra. So what we have to do is distribute the negative. So y plus 1 minus 1/2 y squared plus 3. Okay, so let's integrate this from -2 to 4. And I get y plus 4 minus 1/2 y squared dy. Okay, this video is getting a little long, so I'm going to go quickly on my integral. So it's going to be 1/2 y squared plus 4 minus 1/6 y cubed. And we're going to evaluate it from -2 to 4. Okay, give me some room. So now the hardest part here is just going to again be plugging it in. Take your time. So 4 squared. Ooh, I forgot my 4y here. Whoopsies. Thank you for catching that. Times 4 minus 1/6 4 cubed minus 1/2 -2 squared plus 4 times -2 minus 1/6 times -2 cubed. Okay, so this is going to be 8 plus 16 minus 64 thirds minus, what's that, 2 minus 8 plus 8 thirds. So we get 24 minus 64 thirds minus -6 plus 8 thirds. Ooh, oopsies. This should be 6. And this should be 6. I don't know where I got my thirds from. Okay, so this will be 24 minus 32 thirds plus 6 minus 8 thirds. And I just redo, oh, no. Oops. Let's get part of this back. Plus 6 minus 4 thirds. Whew. Doing math is hard. So we get 30 minus 36 thirds, which is 30 minus 12, which is equal to 18. If you have any questions, please feel free and ask me. I hope this helps, Pumpkin.